Hi kids. So let's have a look at question number 17 from your speed, distance, time, past paper question pack. And this is a superstar question, I called it, because it combines speed, distance, time with upper and lower bounds. So we've done speed, distance, time. We haven't studied upper and lower bounds yet. So I'm going to just try to give you a quick rundown on the method of this question. So hopefully you're going to be a bit more familiar with upper and lower bounds by the time we get to study them. So let's read the question first. And I've got a road that is 4,530 meters long, and it says correct to the nearest 10 meters. And this is where the bounds come in. When it says correct to the nearest whatever, it's bounds. Then Kirsty drove along the road in 205 seconds, correct to the nearest 5 seconds. The average speed limit for the road is 80 kilometers per hour. Could her average speed have been greater than 80 kilometers per hour? I'm not sure I'm working out. It's a 5-mark question, so it's quite a mark heavy question. It's a lot of high level knowledge in here. So let's start by calculating the upper and the lower bounds for the distance, because it says a road is 4,530 meters long. So I'm doing distance. So I want to calculate my upper bound and lower bound for distance, and then I decide which one to choose. So to work out the upper and lower bound, we have to check the rounding that they give me to, or the degree of accuracy that they give me. So it says correct to the nearest 10 meters, which basically means what numbers rounded to the nearest 10 meters would give you 4,530. And there's a set method to do this. So whenever you get your unit here, in this case is 10 meters, I would have to half it. So I'm halving 10 meters, which is 5. And to work out the upper bound, you add this number to your original. So to 4,530, I'm going to add 5, and I'm going to get 4,535. So the longest this road could have been is 4,535 meters. And for the lower bound, geez, my word is playing up today. And for the lower bound, I'm going to take the same number away. So 4,530 take away 5. So that's 4,525. And that's the shortest this road could have been. Now you're going to tell me, well, actually, 4,535 doesn't round to 4,530. But this is where error intervals and stuff like that comes in, which we're going to take a lesson to talk about together. But for now, you just have to memorize this method. So in this case, I've got meters and I've got meters again. And you remember from doing these in class, you always have to check, are your units the same? Not really, because actually they're saying that the average speed limit for the road is 80 kilometers per hour. So that means I need to turn my meters into kilometers and my time, my seconds, to hours, which is going to be lots of fun. All right, so before we do that, I would like us to finish doing the time here, the upper and lower bound for time. So the upper bound, remember, we have to check this degree of accuracy they want, correct to the nearest 5. We divide it by 2. So 5 divided by 2. Obviously, you don't have to write this step. Like, you can skip directly to the upper bound is and the lower bound is. You can do this division and addition in your head. So the upper bound for time is going to be 205 plus 2.5. That's 207.5. And the lower bound for time, we take the same number away. So 205 minus 2.5, 202.5. Like that. So we worked out the upper and the lower bounds for both our values. But we have to remember I've got meters and seconds, which is a bit irritating because I want kilometers and hours. So what I'm going to do now is I'm going to decide which of the upper and the lower bounds I need, and then I'm only going to convert those into kilometers and hours, so I don't waste a lot of time otherwise. So it says the average speed limit for the road is 80 kilometers per hour. Could Kirsty's average speed have been greater than 80 kilometers per hour? So I'm trying to work out what is the highest that Kirsty's speed could have been using these upper and lower bounds. So I will need to do my speed, distance, time triangle. And I know that speed is equal to distance over time, like that. And I now notice I've got a fraction. So I need to achieve the highest possible value, really, in this fraction. How do you get the highest possible value in a fraction? You divide the highest number by the lowest number available. So for me, that means I'm going to do the upper bound for distance divided by the lower bound for time. And that's how I choose my numbers. So I'm going to highlight them just because I can. So the upper bound for distance and the lower bound for time. That's going to give me, ensures that I've got my highest possible answer, highest possible value, so I can compare it with the average speed limit and say if she could have had a higher average speed. So we said we have to convert now to kilometers per hour. So 4,535 meters, we divide by 1,000 and we get 4.535 kilometers divided by, to convert seconds into hours, you need to divide by 60 to get minutes and divide by 60 again to get from minutes to hours. Or what you could do is divide straight away by 60 squared, which is 3,600. So I'm going to do 202.5 divided by 3,600. And that gives me 0.05625. And those are hours. So 202.4 seconds is actually 0.05625 hours, if that makes sense. So now that I've got this, all I have to do is some division. So I'm going to do 4.535 divided by my answer button, because the last thing I had on my calculator was my conversion to hours. And I am getting 80.62 recurring kilometers per hour, obviously. Kilometers per hour. So this means that her speed, yes, her speed could have been greater because it's higher than 80 kilometers per hour. Not by much, but it could have been greater. So conclusion, yes, her speed can yeah, her speed could have been greater than 80 kilometers per hour. You could have just said yes, but I just want to be extra today. All right, so there you go. That's question number 17 done. So try to apply the same idea to question number 18 if you want to have a go independently. Otherwise, I will see you in lesson. Bye.